Question number 9. This question is of vectors. The lines L and M have equations. R is equal to AI plus 3J plus BK plus lambda into Ci minus 2J plus 4K. This is the vector equation of line L. This is the vector equation of line M. R is equal to I plus 2J plus 3K plus mu into 2I minus J minus 3J plus K. In this vector equation, this point is the fixed point, and the vector that is in front of this lambda. Lambda is any scalar quantity. This vector is the direction vector of line L, and this vector is the direction vector of line M. Relative to the origin, the position vector of the point P is 4i plus 7j minus 2k. This vector is the position vector of point P. Part A of this question is, given that line L is perpendicular to line M. Line L is perpendicular to line M, and that P point lies on L. P point lies on line L. Find the values of the constants A, B, and C. First, we write the position vector of P, that is given 4i plus 7j minus 2k. We write the position vector of P, that is OP. We write it in column 4, 7, minus 2. Or simply we can write in terms of ij and k, 4i plus 7j minus 2k. Both forms can be used. Now, since it is given that line L is perpendicular to line M, so dot product of the direction vectors will be 0, because there are two lines L and M are perpendicular. This means that dot product of this vector, which is the direction vector of line L, and this vector is the direction vector of line M. So dot product of these two vectors will be 0. So C minus 2, 4 is the direction vector of line L. Dot product with direction vector of line M, that is 2i minus 3j plus k. We write here 2 minus 3, 1. Dot product is 0, because two lines L and M are perpendicular. Dot product C into 2 plus minus 2 into minus 3 plus 4 into 1 is equal to 0. From here we can find the value of C. 2C plus 6 plus 4 is equal to 0. From here uh, C is equal to negative 5. Now next is given that P point lies on line L. We are taking this point P on the line L as a general point. So P point lies on L. So coordinates of P are, we are taking this point P as a general point. but the position vector of this is given. We will take this P as a journal point. How we will find the journal coordinates of the journal point? This small r is very important in vectors. Small r equal to xi plus yj plus zk always. R is the position vector of the journal point on the line. Xi plus yj plus zk. This is R. Now we compare the coefficients of I, j and k. We will get the coordinates of the journal point. So by comparing the coefficients of I, j and k, journal point will be journal point on line L. Comparing coefficients of I, j and k, x will be equal to x will be equal to a plus lambda c. Similarly, comparing the coefficient of j, y is equal to 3 minus 2 lambda. Comparing the coefficients of j, comparing the coefficients of k, z is equal to b plus 4 lambda. Now putting the value of c, we have already found value of c. Putting here, x becomes x is equal to a minus 5 lambda, y is equal to 3 minus 2 lambda, and z is equal to b plus 4 lambda. Let this is equation 1, this is equation 2, this is equation 3 for reference. Now actually we have to find the values of constant a, b, c. From these three equations, we will find the values of a, b, and c. Now, x, y, z, which are given in terms of lambda, are the coordinates of point P that are given 4i plus 7j minus 2k. This is the position vector of uh, P. The coordinates will be 4, 7 minus 2. These are the coordinates of P. But because P is a general point on the line, coordinates of general point on the line are given in terms of lambda, so we can equate these. A minus 5 lambda will be equal to, this is the x coordinate, but x coordinate is 4 of P. So y coordinate is 7, z coordinate is minus 2. So from here, equation 1 and 2, equation number 1 is we are solving these two equations, equation number 1 and 2. Equation 1 and 2 shows that putting the value of lambda, this x is a minus 5 lambda is equal to 4, because the x coordinate of P is 4, y 7, z minus 2. Equating, we get a minus 5 lambda is equal to 4, and second equation is 3 minus 2 lambda is equal to 7. Now we can eliminate this lambda by multiplying this equation by 2 and this equation by 5. When we multiply this equation by 2, it becomes this equation becomes 2a minus 10 lambda is equal to 8. We are multiplying each side this equation by 2 and multiplying this equation by 5. This will become 15 minus 10 lambda is equal to 35. No subtracting, sign will be changed. These terms are cancelled out. We can find the value of a. From here 2a minus 15 is equal to minus 27, and we get the value of a is equal to minus 6. Now from equation number 2, now from equation number 2, 3 minus 2 lambda is equal to 7. From here lambda is equal to minus 2. Now we have find the value of lambda. Now easily we can find the value of b from here. From equation number 3, from this equation number 3, b plus 4 lambda, lambda we have found already, is equal to z, z coordinate is minus 2. So from equation number 3, we will write b plus 4 into minus 2 is equal to minus 2. B minus 8 is equal to minus 2. From here b is equal to b is equal to 6. Now we have found the values of a, b and c. Also the value of lambda, which was uh, the scalar quantity in line L. Now part B of this question is the perpendicular from point P meets the line M. Perpendicular from point P meets the line M at point Q. The point R lies on PQ extended. Point R lies on PQ extended with this ratio PQ ratio QR is equal to 2 over 3. Find the position vector of R. By these two given conditions, we have to find position vector of R, means we have to find OR. So, line M perpendicular from P, let this is a point P, and this is line M. This line is M. From point P, from P, and the perpendicular from P is this line. This angle is 90 degree. Let this point is Q. The coordinates of point P are given 4, 7, -2. Now Q R lies on this line when extended. The point R lies on PQ extended. If we extend this line, PQ, let R is here. When we extend this line PQ, point Q can be here. This point is Q. We have to uh, find the position vector of R. Sorry, R lies on PQ. R point lies on PQ extended. When we extend this PQ line, R may be here. We have to find the position vector of R. Since these two lines, this line and this PQ, line M and this line PQ are perpendicular, so the dot product of the direction vector of these two lines is equal to 0. The direction vector of this line M is given. Direction vector of line M is 2I minus 3j plus k. But the direction vector, how we will find the direction vector of this line? We will subtract these 2 points P and Q. We will subtract the coordinates of P and Q. We get the direction of this line PQ. Direction vector of M line is also given. So dot product is 0. Now coordinates of P are given, but how we will find the coordinates of Q, since Q is a journal point on this line M. So by comparing the coefficients of I, J and K, we can find we are taking this Q point as a journal point on the line M. So coordinates of Q will be, now we will compare the coefficients of I, J and K in the line M. Again R is equal to xi plus yj plus zk. Comparing the coefficients of I, J and K, coordinate, we are taking Q as a general point, so its coordinates will be x coordinate, comparing the coefficients of I, 1 plus 2 mu, y coordinate 2 minus 3 mu, comparing the coefficients of j, comparing the coefficients of k, we get z coordinate will be 3 plus mu. These are the coordinates of point Q in terms of mu. Now the direction vector of PQ will be, we will subtract these 2 points, we get the direction vector of PQ. So direction vector of PQ will be, we are subtracting 1 plus 2 mu minus 4 x coordinate, this minus this. Next y coordinate will be, y coordinate will be subtracted 2 minus 3 mu minus 7, 2 minus 3 mu minus 7. Next 3 plus mu plus 2. This is the direction vector of line PQ with the dot product of direction vector of line M, which is given in the start of the question. The vector equation of the line M is given. Direction is 2, minus 3, 1. Direction vector dot product will be 0 because these two lines are perpendicular to each other, so direction dot product will be 0. Simplifying it first, 2 mu minus 3 minus 3 mu minus 5 mu plus 5, the dot product 2 minus 3 1, dot product is 0. So simplifying we get 4 mu minus 6 plus 9 mu plus 15 plus mu plus 5 is equal to 0. From here 14 mu is equal to 14 mu plus 14 is equal to 0. From here mu is equal to minus 1. Mu is equal to minus 1. So we are putting the value of mu in here. We will get the coordinates of Q. So putting the value of mu, the coordinates of point Q will be minus 1, 5, 2. Now we can write it in position vector form. So OQ will be minus I plus 5J plus 2K. Now PQ will be P. Now we will find PQ vector, that will be equal to OQ minus OP. These two vectors we have already. OQ minus OP. OQ is minus 152 minus OP is 47 minus 2. We get minus 5 minus 2, 4. This is PQ. PQ is minus 5 minus 2, 4. Now we will find QR. In the same way, QR will be OR minus OQ. Now OR we have to find, minus OQ is minus 152. This is QR. Now, the ratio is given PQ ratio QR is equal to 2 ratio 3. So we can write it as PQ over QR is equal to 2 over 3. So cross multiplying we get 2 QR is equal to 3 PQ. Now we will put here the vectors QR and PQ we have already found. QR and this is PQ. Putting here in this ratio we get this 2QR. This means that 2QR is this OR minus 152 is equal to 3 PQ. 3 into PQ is minus 5 minus 2 4. Now from here this 2 will be multiplied by these two terms. So we get 2 OR minus multiplying this vector by 2 minus 2 10 4 is equal to multiplying this 3 by these numbers. We get minus 15 minus 6 12. Now simplifying we get 2 OR. This term is negative. This will be moved on the right hand side. Then it will be added. This will be added in this. This vector will be added in this vector. We get finally minus 17 4 16. Actually, we have to find position vector of R means OR. We have to find OR. This 2 will be divided by all these three components. So finally we get OR. Position vector of R is minus 17 over 2 to 8. This is the answer, or this is the position vector of R. We can also write it in terms of Ij and K. This is also equal to minus 17 over 2 I plus 2j plus 8 K. This is the answer.